This is a lecture that somehow failed to record. So I printed out the lecture notes and I am going to explain verbally what I did on the first day of classes of this past spring semester, which is a very useful video lecture and note-taking guide for this particular section or sections in this video. So we start the semester with 2.8, solving linear inequalities. And I started by explaining or going through a problem 24 on page 154. So negative 7x plus 4 greater than 3, quantity 4 minus x, and we're asked to solve for x. This is an inequality, the inequality symbol. Obviously, the first step would be to distribute. We distributed, and then we added 3x, and then we subtracted 4 from both sides to isolate x. And then we divided both sides by negative 4. Dividing by a negative number always results in switching the inequality symbol. So that's the reason why the negative 4x greater than 8 turned into x less than negative 2. Now we like to write, and it's useful to write the interval notation for the solution. So x less than negative 2, they're all numbers to the left-hand side of negative 2. And this is the number line or the real line. Therefore, the interval is between negative infinity and negative 2. A parenthesis is used when there is no equal symbol in the inequality symbol, and a bracket will be used if there were a equal symbol there. Our second page, and you have this set of lecture notes in Canvas. So please print them out before you watch this video. 2 less than or equal to x less than 3, such an inequality in interval notation will result in 2 having a bracket and 3 not having a bracket but a parenthesis. Then I picked problem 62 on page 155, and this was the problem. We distributed 2 inside, then we subtracted 8 in order to solve for x, and finally we got 2x. And in order to solve for x, we divided both sides by 2. This is what it's called a compound inequality. There are 2 inequalities put together. This is one inequality, and this is the other. But we do not separate them. It will not be a mistake to separate them, but you will make it more difficult. We subtracted 8, we divided both sides by 2, and this was the interval notation. Then problem 48 on page 154, it had some fractions involved. The best thing to do, the easiest thing to do, is to eliminate the fractions in front instead of distributing them. Distributing them will give us the same answer, but however, I think it will be a little bit more difficult. So we decided to multiply both sides by 6 because 3 and 2 have the least common multiple, or the least common denominator, 6. So multiplying the left-hand side by 6, 6 over 1 times 1 over 3 is 2. The right-hand side, 6 over 1 times 1 over 2 is 3. We do not multiply 6 inside. We only multiply it outside because multiplication is commutative and associative. This times this will give us an answer, and that answer will be distributed inside. The same thing on the other side. So 2 quantity 3x minus 1 less than 3 quantity x plus 4, we distributed. We subtracted 3x from both sides and added 2 to both sides, and this will take us to page 3. So it results to simplified inequality, 3x less than 14. We divided, and we got the interval notation, all numbers to the left-hand side of 14/3. Then we looked at problem 70 on page 155. It's about the number of people, maximum number of people for a total of 860 budget. $40 is the entrance fee or the standard or the fixed fee, and $15 per person. So we want to stay within the budget. So $15 per person plus the flat fee less than or equal to 860. Our budget, we subtract 40 and we divide by 15. And the maximum number of people that we can invite for this venue, for this gathering, is 51 or less. So 51 is maximum. Then we moved on to 9.1, compound inequalities. And we talked about union and intersection first. Union of sets, union of intervals, intersection of sets, and intersection of intervals. And this takes us to page 4. So these are two sets. They are presented with braces. Whenever the set is presented in the roster notation, we use braces. And also when we present it as a set builder notation, we also use braces. So this is a roster notation. I picked two sets, set A and set B. In order to determine the union of those two sets, we have to write all elements only once. So from all these, we realize that this is the union. -4, -3, -2, 0, 5, 7, and 9. The intersection requires only common elements. Well, these two sets have two common elements. They have 0 and 5 in common, and that is the intersection of those two sets. Another example in which the intersection of these two is the empty set. The empty set, or the phi. Phi is the Greek letter that represents the empty set, or just write the braces with nothing inside, which means no element is common to both. Now, here I picked, yes, two intervals. So the first interval goes from 2 to 3. So this is the first interval. And the second interval is between 1 and 7. So this is the second interval. And we're asked to perform the intersection. That's the symbol for the intersection. So therefore, when we intersect the two, the intersection is between 2 and 3. So the green set is intersected with the red set. Therefore, the red set is indeed the intersection. However, if we want to determine the union of these two sets, we are writing all elements only once. So assuming I have the set between 2 and 3 and you have the set between 1 and 7, and we put those elements together we can enjoy 1 through 7. So that's the union and that's the intersection. That takes us to page 5. So the union is associated with the keyword or, and the intersection is associated with the keyword and. So here's another compound inequality connected by, or I should say two inequalities connected by the keyword and. We solve the first inequality subtracting 4 and dividing by 2. We solve the second inequality divided by 4, and we get x greater than 0. Therefore, we have two intervals. Greater than -2, which is this interval, the green interval, and greater than 0, which is the red interval. Therefore, I'm asked to intersect those two. I'm intersecting the green set with the red set. Obviously, the solution is the red set. If I change the problem now, and I change it to or, so the keyword now becomes or. Here's the difference. So the sets do not change. The green set is the same. The red set is the same. However, the union will be -2 to infinity. Why? If you have the green set and I have the red set, and we perform, or we let's say we make up a partnership, we will be able to enjoy this set this time. Although we have this in common, this would have been the intersection. The union of the two sets is what you have and put on the table if you want, or bring to the table, and what I have and I bring to the table, and we will both enjoy this set, not just this set. So the union is the -2 to infinity. The intersection is 0 to infinity. That brings us to page 6. Another example in which x less than 2 or x greater than 3. Less than 2 is the red set, and the greater than 3 is the green set. This time the keyword is or, which means the union of the two sets. So if you bring this to the table and I bring this to the table, we both will be able to enjoy this, which is the union. It cannot be written in any other way. The next example was x less than 2 or x greater than negative 3. Less than 2 will be the red set, and greater than negative 3 will be the green set. Therefore, you bring the red set to the table, I bring the green set to the table. What can we enjoy together? It turns out that we will enjoy together everything between negative infinity and infinity. You bring this, I bring this. This is what we enjoy together. Now, the intersection of those two sets, if I'm asked to create or determine the intersection, less than 2 with greater than negative 3, the intersection is right in here. These are indeed the common elements between negative 3 and 2. That takes us to page 7. Another example, x plus 9. This is problem 42 on page 558. X plus 9 less than 0, which results in x less than negative 9. The keyword is or. 4x greater than negative 12. Divide both sides by 4. So the keyword or again. So this is the red set. Here is the green set. And now we are asked to create a union. You bring this to the table, I bring this to the table. What can we enjoy together is the whole thing, of course, with a union, missing this portion. Now, problem 70 on page 558 is slightly more difficult. It requires more work because it has a lot of fractions. Negative 1/4 less than 6 minus x over 12 less than negative 1 over 6. Well, what we have to do first is multiply by 12 in order to eliminate each fraction. 4, 12, and 6 have a common multiple, or the least common denominator is 12. So 12 multiplied by negative 1/4 will be negative 3. 12 multiplied by 1 over 12 will be 1. And negative 1/6 multiplied by 12 over 1, this will give us negative 2. So take it from here. We are subtracting 6 from all three sides. Negative 9 less than negative x less than negative 8. However, we have to divide by negative 1. When we multiply or divide by a negative number, we have to switch the inequality symbol. So negative 8 becomes 8, negative x becomes x, and negative 9 becomes 9, but of course they have to be switched. We read the inequality from the smallest number, 8 less than x less than 9. Therefore, the solution is 8, 9. That brings us to page 8. If I am told, or I tell someone that I have between $10 and $25 in my pocket, in mathematical terms, this is what I mean. I have an unknown number of dollars between 10 and 25, which can be presented in interval notation in this way. Now, problem 94 on page 558, it's asking us to find what will be the score on the final exam of a total of 6 tests for a B in the course as the final letter grade. B means that the final course average must be between 80 and 89. So we are given these 4 grades on the first 4 tests, but we do not have the final exam that happens to count twice. Counts twice. Therefore, we have a total of 6 tests, 6 test scores, 1, 2, 3, 4, 5, 6. So the average for a B, the average scores must be between 80 and 89. The average of 6 numbers is their sum divided by 6. Therefore, we replace the average by their sum, 1, 2, 3, 4, 5, 6 scores divided by 6. We multiply all 3 sides by 6. After we combine these into 327 plus 2x, twice x is being the grade for the final exam. Then we multiply all 3 sides by 6. We get this, and then we have to subtract 327 from all 3 sides. That brings us to the last page of this lecture. And we have 2x left in between, and then we divide by 2. Therefore, you can tell your colleague or yourself, well, if in order to get a B in this class, I have to obtain a final exam grade score between 76.5 and 103.5. Last problem was problem 92 on page 558 about the temperature range. So we are told that this is the formula that this is given to us that connects or transforms Celsius temperatures into Fahrenheit temperatures. And we are told that the range in Celsius is between -10 and 18. And this is exactly the same idea of me telling you I have somewhere between $10 and $25 in my pocket. So C must be between -10 and 18. We replace C by what it's given to us, the formula 5/9 times in quantity F minus 32. We have to get rid of 5/9 first, and I multiply all three sides by 9/5. And I perform the operations 9/5 times -10/1, and that gives us -18 by simplifying by 5. Here 5/9 disappears, so the middle part is only F minus 32. And then on the right hand side I have to multiply and I get 162/5. Therefore, final step, we have to eliminate the 32 from the middle part. We add 32 to all three sides, and that is the final answer. The temperature in Celsius, when the temperature in Celsius degrees is between -10 and 18, that translates into a range for Fahrenheit temperature between 14 and 64.4 degrees Fahrenheit. And what I was telling my students then was that to redo the notes, do all the problems to that 8 and 9.1. Of course, read the text and do the odd number problems and check in the back. Thank you.